got this reference FSAE car, so this just has my geometry from SpaceCam that we were previously playing with. It's got the fluid domain, it's got the bodies of influence, and it's also got the name selections as well. Alright, so I'm just going to copy and paste this, just keep a record of this place here. So I'm just going to open up Fluent as a standalone, so I'm just typing in Fluent into the workbench. This is what comes up. Right, so dimensions wise, I'm looking at 3 dimensions. I normally just don't show the workbench controls or the mesh after reading. I don't have any ACT options. I'd like to be using meshing mode, double precision. So currently this should use around 8 decimal places. With double precision, you'll see it'll go up to 16. I personally haven't found a huge change in the results using double precision, but I think it's something that everyone should check. Right. In processing options, we want to be using parallel. So in CFD especially, all the computer really cares about is how many physical cores that you have, not about any virtual cores. So if you've got a computer and it says, you know, it's an i7, a new generation i7 with 8 cores, the truth is it's actually got 8 physical cores, but 8 virtual cores, where you've got 4 physical and 4 virtual. So we just want to be using 4 processors for the processor and the solving. And when it comes to GPUs as well, if you have any high-end GPUs like any of the Quadro ranges or any of the high-end GTXs, you can utilize your GPU for solving. There is a component of the mesh of the solver that can be thrown into the actual GPU in order to be solved quickly. However, it requires that the whole mesh needs to be put into the solver. So it means if you've got something like an 8 gig card, you might not be able to get away with a very big mesh. So that's something you might need to test out on your own machine. Now in the working directory, I'm just going to take the directory that I've got my SpaceClaim document in, Control copy and paste it into here. I'm going to just press OK and it'll start itself up. So it's just starting up on my other screen. I'll take it over. Again, if you guys, if I'm going a bit too fast because I can't quite see if there's a huge amount of lag on your computer, just let me know. And I'll slow down as much as I can. Okay, so this is Fluent meshing. It's very similar to the Fluent page, the Fluent solving side of things that I'm sure a lot of people are familiar with. On the right hand side, we've got some GUI controls. We've got a console underneath. If I hit enter, you can see that there are more options. In this console, you can also write in text user interface options in order to make your life a little bit easier. You can actually script your whole mesh, which I can help people with later on as well. On the left-hand side, we've got our normal tree, and we've got a ribbon at the top with some options at the top here. All right. So what we'll do first is I will import our geometry in. We'll go File, Import CAD. I'm going to import a single file. Just click on the 3 dots and select the reference FSAE car. Now I'm going to take in a CAD faceted data. So what it does, it'll take the whole CAD in, but it won't create any surface mesh. It'll take it in almost like an STL, and that's exactly what you'll see. All right, so I'm just going to import that. So I'll let it do its thing. So again, Fluent and Fluent meshing, you'll be able to import almost every file format. Brilliant. So now on the left-hand side, we can see that we've got a geometry object that we've taken in. If I select the arrow, it'll just it'll fill out the drop-down, and I'm going to go right-click on the enclosure and hit Draw. So I'm just going to move that around just using my left mouse button, and I'm going to hit my Face Edges display option over here. You can see on the left-hand side, I've got the zone selector filtered. If I right-click on it, it'll highlight that. If I go Control right-click, it'll actually remove it. Again, Control right-click on the inlet, outlet, and the ground. I'm just going to zoom in using the zoom button into here. You can see it's brought all the data in as if it was an STL. Right, so normally it's important to go through and just double check everything. So there are some geometry options within SpaceClaim, within Fluent in order to fix up any dirty geometry. So if you have something that isn't a watertight body, you can do that within Fluent. What will happen though is that because we've taken it into SpaceClaim before, we've made everything watertight, we don't really need to go through that step. So what we can do, if we show this, we can see that we've got some face zones labeled in as well, right? And what we're going to do first is create a surface mesh, and then we're going to re-import that surface mesh in with the geometry. So I'm going to go right click on the model, sizing, scoped. So this is a little bit like creating all my my sizing features. So I've got my global scope sizing on the right hand side, and I'm going to change this. Instead, when I go from, it's again because I've done this before, I kind of have a pretty good understanding of what to throw in here. You might want to play around with this a couple of times to understand your geometry, but we'll go for a 1 mil minimum, a 500 max with a growth rate of around 1.2. We're going to press apply. Now, it's again, there are a couple things that we need to add. We've got 2 bodies of influence, so I'll do those first. I'll look at the name. I'll go BOI dash far, and the type is a BOI, right? This BOI is going to be around 50 mil max, and what I'm then going to do is select these 3 dots, and I'm actually going to I'm going to invert selection as shown. I'm going to select the far BOI. I can draw it if I need to, just to make sure I've drawn the correct one, and press OK, and I'm going to create that. So now I've actually created my first sizing. I'm going to do the same, and I'm going to call it BOI near. Again, type BOI, closer to the car, I'm just going to give it a 20 mil max, a 10 mil max, growth rate of around 1.2, and instead I'm going to select these 3, select the 2 buttons here. I'm going to draw it just to make sure I've selected the correct ones, press OK, and then create that. Now I've also got a curvature sizing. So the curvature sizing, I'm just going to draw the front wing. Curvature sizing around the front wing is just to ensure that we can resolve the nose of the front wing, right? So I'm just going to call it front wing curvature. So it's going to be a curvature type. It's going to go from a minimum of 1 to 10 mil, growth rate of around 1.2, and I'm just going to change this normal angle to 18. Right. Now I want to select a face zone, so I'm going to go here, face zone, triple click. I'm going to just deselect everything. I've got my front wing here. I'm just going to draw it. It's already drawn that one. Press OK and create. I'm going to do something similar for the front wing, but it's going to be proximity. So this is going to ensure that we've got 3 cells across the gap of the rear wing, of the front wing, sorry. So we can see we've got the gap across there, right? So again, front wing dash PROX. This is a proximity feature. It's going to go from a minimum of 1 mil to around 4, and I want 3 cells across any gaps. And I want to have it though not across any faces but across any edges. It's again 3 dots. I'm going to deselect everything. I've got a bunch of name selections here. I'm just going to look for the ones that say front wing, and I'm going to double check it by pressing draw. It's again so that makes sense because we've got the trailing edge which has a gap there. So we'll have one there and around there as well. Press OK, create, and now I'm going to create one for the rods. I'm just going to call it rod curvature. It's going to go from around 4 to 10. It's the face zone. I'm going to deselect everything and call it rod. I'm going to press OK. Just real quick, guys, is the speed all right on your end? Is everyone seeing what I'm doing? Just chuck it in the chat menu if you have any issues. No, or you can pose a question or anything like that. Cool. All right, so it looks fine on my end, so I'm just going to continue on with that. So it's again rod. I'll create that. I want to create one around the wheels as well. So go wheel curvature. It's going to go from 15 to 20. Wheel, press OK, create, and I'll need one around the stand as well. I'm going to give that 1 to 4. Press OK, create. Now what I'm going to do is I'm going to compute the size field. So I'm just going to go hit compute here, and before I take it back in, I'm just going to go select this, right click and remesh it. So if you exit out, again, it's remesh this whole thing. Control, right click, control, right click. When I've got the zone selection filter, right? So I'm just going to zoom in. Looking at the top, I can see I've got my bodies of influence. So on the outside, you can see it's created a tech grid, which we'll do initially. Outside is relatively large. I've got a far field, and I've got some resolution around the wake regions as well. If you zoom in, you can have a look at how big it is around the tire, right? How big it is around the wing as well. You can see I've got the curvature around the wing picking up that nose, right? And then I should have a couple of elements across the gap as well. Now you can see here straight away I've actually forgotten to add a sizing on this chassis, and it's got quite a large sizing. It's quite skewed. Right, what I'm going to do, I'm going to right click, I'm going to delete this, including faces and edges. Right click, select the sizing, scoped. I'm going to delete the size field. I'm just going to add another one, call it chassis. Curvature, it's going to go from 10 to 50 mil. It's a face zone. I'm just going to select. Now I don't actually have a selection for the chassis, but what I can do, if I have a look at enclosure, I can draw it, and I can notice that anything that I haven't actually given a selection to, it's automatically given one by itself. So I'm just going to press OK. And I'm going to compute that, close it, right click, remesh, and I'm going to check my surface mesh out. So it's again very important to make sure that you check your surface mesh and you've got a good quality. Again, control right click, get rid of all this. Still not that great around here at all. So what I can do, I want to select these nodes to figure out how big this is, right? So I'm going to select the node selection filter, right click here, right click here. On the top right, I can examine. I can see that it's trying to give it a 50 mil, right? So again, right click, scope sizing. Let's delete the size field. Let's have a look at our chassis. So okay, so it looks as if when I created it, I didn't actually hit create. So let's just redo this again, 10 to 50. Yeah. Awesome. Right, now we've got the chassis in there as well. So we've given it a minimum sizing of 10. So hopefully around that curvature part over there, will give it a 10 mil sizing. So again, compute. I'm just going to delete what's already been created. Right click, remesh. Okay. Again, so I'm in the node selector. I'm just going to go to the zone selector again. Just get rid of everything. And now it's resolved a little bit better. Now it is a bit coarse around a couple of these edges, but I'm not too fussed with the resolution around here because I'm more so interested in about the lift and drag created by the front wing. So again, we can see that it's resolved nicely around the actual nose. Underneath as well, it's resolved well. Now, I didn't add a proximity around the end plate, but now you can see what's happened when I haven't done that. It's created all these elements across here. right? You can also see, because I've got the body of influence, it's also refined a little bit around the chassis as well. Cool. Alright, so there is another way. So instead of going into the mesh object, I can go back and create a size field and bring it back in, but this is a little bit quicker. I'll just do it this way. Alright, so I'm just going to right click and draw everything again. What I'd also like to do is just check my surface mesh quality. So right click, summary. Okay, so you can see here I've got free faces, multi-faces, so it means the mesh hasn't quite come in appropriately. So if I select these faces, I can see I've got these faces here that have all been highlighted. Right, so these ones, they've got issues with how they're all connected. Alright, so if that's the case, what I'll do instead, I'll go File, I'll write out a size field, test-1, I'm just going to press OK. And what I'm going to do now, so I'll go back and I'll re-import the CAD. And I'm going to add a surface mesh. I'm going to use the size field option. And I'm going to use the size field that I've just created. All right. I'm just going to press import. And you can see I've got all these free faces and multi-faces. But when I import this size field in, it's going to get rid of that altogether. So this is a very quick run through of what's happening with Fluent meshing and Fluent. Well, what we'll do is I'll have more tutorials out there for people to wrap their head around and understand. Any more questions until this thing starts to fire up? Brilliant. So you can see that it's deleted the geometry objects and it's just imported in the mesh objects. So I'm just going to right click and draw the enclosure. Right. So I'm going to go face edges again, so I can see it's brought everything in. And when I select multi-faces and free faces and multi-faces, nothing's coming in. So those free faces and multi-faces are just elements that may not quite line up. So they'll cause errors down the line. But by saving out the sizing function and importing it back in, it removes all of that. And now what I'm going to do, I'm going to go right click on summary again. And you can see now my mesh metrics almost. So everything's a bit skewed because of the enclosure -1, but we've got skewed faces. We've got 30 of them that are above 0.85, with the max skewness being 0.99998, and this is how many faces we've got altogether, right? So again, like I was talking about before, this is just a surface mesh. No volume mesh has even been created. One of the benefits you can do is go in and start to move objects and understand exactly where your bad elements are. So let's have a look at, sorry, we'll go here, right click, diagnostics, connectivity and quality. Right, so what am I interested in? So I can select all the boundaries, not really interested in bodies of influence. I know from experience that my ground, inlet, outlet, or my symmetry aren't really going to give us any big issues, or my wall, sorry. So I'm just going to redraw that. So now I've just got these features here. Let's have a look at the quality tab. And again, so we know that we've got 30 cells in the 0.85 region. So if I leave that as 0.9, what I can do, I can actually mark everything. And if I go first, it'll actually show me where these elements are. If I hit the up arrow, right, it'll start to show me more of the mesh. So you can see I've got a very bad element around that area. If I go next, again, it'll just continue to do this. So it'll show me where all my bad elements are. So what you can do afterwards is have a look at where all your bad elements are and understand, is it an issue with geometry, right? So let's just recenter this. In this particular case, I've got a radius around here which I haven't quite resolved, so I can potentially get rid of that altogether. And I've got this upright that's intersecting with it in a very weird way. So I could potentially just go back and remove these features from the actual geometry in order to improve the surface mesh, right? Again, right? And what I'm just going to reset everything. So with skewness of above 9, I'm just going to go into the operations of general improve. And I'm just going to apply to all. And what it's going to try to do, it's going to go back and try to actually remove or move nodes and cells in order to improve quality. Right. All right, so now if we right click and press summary again, we can see that we've only got 6 faces now that are above that skewness. So if I go 0.85, again, I can go back and mark it. I know I've got 6 of them. If I go first, it'll show me exactly where this is. All right, so I'm just going to press up, 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 up. All right, so I can see where the rod attaches to the upright. I've got a very tight, very close surface to here. That's causing me some bad error, some errors. It's again, I can go back in the meshing, in the geometry side of things, and actually remove these kind of arms, or I can move them closer together to get them away. I'm just going to go generally improve for now. Again, right, so we've got a couple of iterations at the bottom here. Right click summary. I've still got a couple of faces, so it's again mark, next. Right, we can go through this whole process and we can see a lot more of them. We're just going to go apply to all. Now if they're not helping out at all, we can always collapse these elements. General improve. If we go right click. So by doing that, we've actually increased, made a couple of the cells worse. So let's see if we can do anything else. No. No. Right, so let's mark these. Where are these located? Alright, so we've got some bad quality elements again around there. And there as well. Alright, we'll leave it for now, but we can always go back and improve the quality around that area. But hopefully by doing that, you can understand exactly what you can do with Fluent and Fluent meshing. Right. And now after we've done that, we're going to go here, right click, and we're going to compute our volumetric regions. So we've got the enclosure. Now it's not, we want to change the type and tell it that it's actually a fluid zone. We're going to press OK. And if we right click on that, we can start to mesh the actual object. Now we've got poly Hex Core over here in the volume field, but it's grayed out. And that's because it's a beta function within version 19. But what I'm going to do, I'm just going to activate that. So I'm going to hit close. I'm just going to hit enter. And I've got this text user interface. So if I highlight this and select my middle button, I can press enter, and I'd like to say yes to enabling beta features. That's okay. If I go right click, auto mesh, whoops, let's just do that again. Brilliant. Now I've got poly Hex Core available to me. Right. So it's again the object that I'm looking to mesh is my enclosure. I would not like to keep any cell zones. I would also like to grow some prisms. So these are the prism layers in order around the front wing for inflation. So I'm going to scope them. I'm going to set that. So I'm just going to give it a name. There are 3 different types of offset methods, but I'm going to choose the last ratio. Now, if I'm not sure which method is the best, I can always select this help function. So what it's going to do, it's going to open up a web page for me. So in ANSYS 19, all the help has been taken away from an executable, and it's all online. So if you go down, you can have a look. It'll tell you a little bit more about what's happening, what you can do with it as well, and the different options within the Fluent mesher. All right, so I'm just going to exit that. But I know I want, it's again, because I played around with it, I know I want a last ratio. I want it to be around 0.02. Now I normally want around 18 layers to pick up everything, but I'm just going to give it 10 for the moment. I'm going to get a last percent of 20 mil. It's only going to be on walls, on selected face zones, and I'm going to select my front wing. I'm going to draw that just to double check. Awesome. Press OK. Create. I'm going to close that. Now quad to tet transition, I'm going to leave those pyramids. Volume fill, I'm going to leave as polycore. I want 2 buffer layers, 1 peel layer with a minimum cell height. Again, what does all of that stuff mean? So if you go down, let's see if we can find some more information on poly Hex Core. So let's just type in poly, press enter. We can see the very first one is the Fluent beta feature for poly Hex Core. Let's select that. Again, so this is the text box that we were seeing previously. And if you want a little bit more information, if we go back one, no, let's just go back again. Oops, let's go poly Hex Core. Just research that. That's all right. All right, so I'll find some more information on that as well, and I'll send it your way. But then afterwards, what we can do, it's again, we'll want to merge the cell zones within regions, because we've got a cell zone that's full of prism layers. We've got a poly region, and we've also got a hex core region, a hex region, sorry. So I'm just going to hit mesh. Now this is going to take a couple of minutes for it to mesh. Brilliant. So the mesh has been created. So I'm just going to right click and draw the boundaries. All right. I'm just going to get rid of that. And I'm just going to have a look at what's happening around here. So I'm going to go node selection filter. I'm going to select a node, and I'm going to have a look at the X range. Right click, draw cells in range. Brilliant. Now I can see that, again, I've got my prism layers that I've created. All right, transitions into poly, and it transitions into hex core afterwards. You can see I've got my refinement region around here as well, and it transitions from the near region to the far field to the outer field as well. Awesome. So I've created everything that I've wanted to when it comes to my mesh. So instead of exiting out of it, I can write out a mesh file if I want to debug it later on, but I can also go switch to solution, and what it should do, it'll delete anything that we don't need and just bring in the cell zone into Fluent solving.